In this lesson, we're going to be solving this problem. This problem is under the thermal expansion. This problem, it reads as follows. At 290 K, the dimension of the square metal plate are 350 millimeters by 350 millimeters. So at this temperature, the dimension of the plate is this. That means this is T1. This is area 1. Then the temperature increase from this 295 to 400 K here. Then also the dimension increase. Here it is matching with this temperature. So that means this dimension is for area 2. This is temperature 2. Then they said calculate the coefficients of linear expansion of this metal. We first calculate this area. Say area 1 is equal to 350 millimeters by 350 millimeters. Then this is gonna give you 1.225 times 10 to exponent 5 on top. Then this is millimeter squared, like this, which it goes with the temperature T1, of which is 295 K, like this. Then let us come to area 2, which is 351 millimeters by 351 millimeters. Then this is gonna give 1.232 times 10 to exponent 5 millimeter squared. Then this, it goes with temperature 2, which is equal to 400 K. Then because here we're looking for the coefficients, these coefficients of linear expansion, because here this statement is talking about the dimension of the area. That means we're gonna use the change in area formula, which is this. Change in area is equal to initial area, which is area 1, times the coefficients of area expansion times the change in temperature, like this. These coefficients of area expansion, it link with these coefficients of linear expansion. How? The coefficients of area expansion, it is twice of the coefficients of linear expansion. That means we have to get these coefficients of area expansion to get these coefficients of linear expansion. So this we'll get it from this formula. Let us do it. Change in area, like this, it is equal to area 2 minus area 1. Then also let us say the change in temperature, it is 400 minus 295, which gives us 105 K, like this. Then here let us come back to this formula. Let us make this coefficients of area expansion a subject of the formula. It is a coefficient of area expansion is equal to this, which is change in area divided by the initial area and times the change in temperature, times the change in temperature. Then when you expand this, it's gonna give you area. Put that back as it is, area 1 times the change in temperature. Then let us substitute. Area 1, it is, no, area 2, it is 1.232 times 10 to exponent 5 minus, no, here it's area 1 here, minus area 1, which is 1.225 times 10 to exponent 5. Then divide all by this, which is area 1. Area 1 is this one, it is 1.225 times 10 to exponent 5. Then times the change in temperature, which is this one, 105. Then from here we get the coefficients of area expansion to be 5.44 times 10 to exponent negative 5 per Kelvin. This is gonna be 54.4 times 10 to exponent negative 6 per Kelvin. Because we found it now, we take it back to this formula. It is the coefficient of area expansion is equal to 2 times of the coefficient of linear expansion. Let us make this a subject of a formula. It is a coefficient of linear expansion is equal to the coefficient of area expansion divided by 2. Let us substitute. This, we've got it now. It is here 54.4 times 10 to exponent negative 6 divided by 2. This is gonna give the final answer to be 27.2 times 10 to exponent negative 6 per Kelvin. That is the coefficient of linear expansion that we're required to find from the problem. I hope you have seen what I did here. Please pay attention and follow it step by step. Pause where you have to pause. Look at this. This problem statement here at first is supposed to be say at 295 Kelvin, the dimension of the squared metal plate are. So, but our goal was to find this a coefficient of linear expansion. Then we did everything that we could here. Then we finally find the coefficient of a linear expansion to be this from the coefficient of area expansion, where we have used the change in area formula. Then we found the coefficients of area expansion which we used here